Okay, so thanks for joining and for being patient about this. It's going to be a difficult task, I think, but we're going to figure out a way. I'm using a software here. It's a whiteboard or a blackboard, okay? So we will have different methods to try and write things down. The goal of today's session is basically to show you mainly what the course is going to be about and start with a very few I think you have the slides available on the website. It's the only course that I have put the slides on the website. I think you must have it. And we are going to work around this. This is the support that we are going to be using during the entire course. And the book that I used to build that to build that course is basically the Barrow textbook that some of you have tried to download on the website. So what I will do is we will talk a little bit about this course now. We will do the quick introduction about the topics and how are we going to deal with things. And then at the end I will show you the resources that you can use in the books, for example, which parts you can actually focus on. And then if you have questions, that would be good to try to take them now. And voila, we'll see how to advance with this. I'm talking in English. It's not because I cannot talk Arabic. It's just that we are recording this, and at some point this is going to be on YouTube, private, but you never know. So yeah, we can make it accessible for everybody. So if the courses pick up very well on YouTube, then I will be making a lot of money. So why not? It's much better than actually keep doing courses in Arabic. Great. Perhaps I would like to know, to start with, and perhaps I can hear from some of you, why have you chosen basically to start or to take this course? Why are you interested in learning more about molecular physics or molecular spectroscopy? So if you don't mind, perhaps you could just say, and if you are hearing each other, then just keep that rolling smoothly. Would someone tell me, please, why have you chosen to take this molecular physics course?
Because it's related to my Master 1 project.
To your Master 1 project?
Nanotechnology.
Okay. So now I see Hannah. Hannah can actually, you can talk, obviously, no worries. Let me check.
Okay, I've searched about it, and it can molecular spectroscopy can reveal the form and structure of molecules and chemical info about it, and I thought it was interesting to study.
Okay. Great. Anybody else has different interests or? Well, you can still raise your hand as Hannah did. I think it's a nice feature in the Zoom software, so you can interrupt me if you want by just like raising your hand, so I will see that. Good. Well, thank you for answering. I mean, Hannah answered. The nice thing is I don't know your faces, so I have no idea who I'm talking about. Who I'm talking to, but I don't know the other person who answered me was. Could you give me your name, please?
Sultan.
Sultan.
Yes.
Okay. Well, great. I mean, we will try to just build something more personal out of this online thing, because we will try to replace the class. The class experience is much nicer. Great.
Yes, of course.
Thanks, Sultan and Hannah. You're right. Molecular spectroscopy is basically the way that we could it's the way that we could actually probe or interrogate any material, matter in general, using radiation. So, in fact, if you consider any sort of, let's say, a surface of a material, right? And yeah, say this is silicon, for example, or silicon nitride. Okay? So basically, what interests you as a researcher, or as a physicist, or as a chemist, sometimes even biologist, is to know this piece of material that I have, what is it made of? Or for example, what the surface of it is made of. Is there any specific type of species on the surface? Are there any kind of molecules that we are actually collecting or putting on the surface or whatever? This sort of information, the way we can probe it usually, and most of the time in physics, is through an interaction that matches basically what Sultan said at some point for the M1 and M2. It's the interaction, if you want, between the light and the matter. Well, you will see that nicely now. Voilà. The interaction between light and matter allows us actually to send light, to send photons into a material, and then to collect whatever goes out of it, either photons or even electrons sometimes. So we can send photons and we can collect photons, with a difference in their frequencies or energies, obviously. Now, what happens on the material level? So, again, if I take, oh no, it's red, it's fine. So when we actually send a photon to a material and then we collect another photon, this is at the frequency nu and this is at the frequency nu prime. Now I'm saying these things assuming that you know this, but you will see it in the slides. It actually tells us more about it in details. Anyway, usually we send light. The light interacts with the matter on the surface level or in the bulk level, whatever. Here there is an interaction between light. So it's going to be a bit tricky to write without a pad, but it's fine. It's interaction. So an interaction happens here between the light that is incident to the sample, it interacts with the matter, and then it reflects back or it goes out back in a certain way that we can collect. So here we have a source of light and here we have the collection of light. Okay? This phenomenon, all this that is happening, all this sort of interaction and sending, is basically the core of understanding materials in physics, in science in general. Because this red thing is not necessarily just a piece of metal or a piece of organic material or whatever. This could actually be cells. This could be tissue. This could be any sort of material. Because at the end of the day, on the very small scale of matter, all the disciplines of science are connected. So even biology at the end of the day, it's about cells. And cells are molecules, so that's chemistry. But molecules are atoms and forces between atoms, so that's physics. So at the end of the day, everything boils down to physics. And this is why physicists are strongest, or the strongest to understand things, to be honest. It's said by a physicist, but yeah, you should be proud to study physics because it's one of the most fundamental things to do in science. However, our goal is to understand this part of the thing, what is going on between the light coming to the material and the material itself, so that this light that we collect is actually different than the light that we send at the beginning. This interaction is at the core of this course. So this matches what you said. The goal of this course, excuse me, is to study the structure of molecules forming a certain substance through the investigation and analysis of radiations emitted or absorbed by the substance. Okay. So for example, and I usually take these examples, and especially in this course, it's going to be around these sort of examples. So if anybody has a problem with these examples, please just let me know so I stop using them. But that's my method. Imagine that you go to the university and it's a band of boys gathered together and they look around and there is another band of girls. And then one of these guys is interested to know if a particular girl of that group is actually available for talking or for a relationship. So what would this guy do? He will actually send someone from his group of boys to the other group of girls. Okay? Or he might use a girl, a friend, to send her to the group of girls, so she will talk to them, she will interact with them, and then she will get back him with an information or a sign or whatever, a code. So based on this code, the boy will understand if the answer is yes or no or maybe, or you have to work hard or just go do something useful in your life or cut your hair or whatever, right? So this is what we are going to do in physics with molecular spectroscopy. We will send someone to a material and see who is available in that material. So yes, we are going to understand the structure of molecules, because molecules are building blocks of the matter itself. Okay? Great. So this is going to be achieved. By understanding the relationship between the frequency and intensity of the radiations emitted or absorbed by the substance to the internal molecular properties of the substance. Okay? So that's what I just said. It's just written down. Great. Okay. Mm. Well, this course is not a big one, huh? So it's just 30 hours per semester. We have very defined topics. We are not going to go deep into them, huh? You will say it's not very fundamental in the sense of the theory itself. It's more fundamental in the understanding of the experimental data. So if you do this course now, and you get access to a experimental spectrum, experimental results, you would be able actually to analyze them. This is the goal of it. So it's really an applied sort of physics course. So this would allow you to understand what a spectrum means, how it would look like, what sort of information different spectra type infer, and how you could actually get into this information and analyze the spectra. Okay? So, the first chapter, chapter 1, it's about basic notions in radiations and quantum mechanics, and about very fundamental basic understanding of absorption and transmittance of radiation by matter. Basically, this chapter with its exercises should take 1 week. Okay. Now we will see how we are going to manage this one and these sort of things with the online, but yeah, it should not take too long. Chapter 2 will be about the rotation of diatomic molecules, so what we call the spectra of rotation. So as I said, it's really about spectra and understanding them and analyzing them and cracking out data. Chapter 3, it's about vibration of diatomic molecules. So I will explain that later, rotation and vibration. Chapter 4 is the vibration rotation of diatomic molecules. And finally, chapter 5 is about electronic transitions in diatomic molecules. So when I say rotation, vibration, and then electronic, we will see this in this basic notions on radiations and quantum mechanics, but basically each molecule, let me get back to this. You go up now. Up. Oh. Okay. This is good. Okay, so let's take an easy molecule, say, I don't know, oxygen, the oxygen atom, say it's like that, and then I will take 2 hydrogen atoms, okay, and I'll connect this with bonds, okay. So understand very well that the bonds basically at the end of the day, so this is oxygen and these two are hydrogen. So that's the water molecule, right? H2O. Perfect. Let's write it down because this is going to be at your service for later, so you can use it. So H2O. These are the yellow. Sorry. So the yellow lines are just bonds. Bonds, they do not exist in reality, right? There is nothing like a string, for example, that you can pull in or out to say that this is a bond. Bond is just a force or a field in an empty space. So if we go to a molecule, if we go to look into a water molecule, right? We will just see if there's a way to see, and there is a way to see, that I will talk to you about it later. So we could actually see, we will see an atom here, and then two atoms there. Nothing in between, just empty space. So physically speaking, it's an empty space. It's just filled with forces or fields of interactions, which keeps these molecules or these atoms bonded together so they form a molecule. Great. Now, this means that basically these atoms, they actually are surrounded by nothing, basically, by fields. So they have some degrees of freedom. These degrees of freedom means that these atoms could actually either do rotations around themselves in one direction or the other, like this, or actually they can go like this. They can actually sort of, if you want, move around, or like this. They can do all sorts of things, like this, like this, like this, like this, etc., etc. Now, these degrees of freedom, the movement of atoms in the molecule, each one alone and the whole together, actually form the energy that the molecule has inside the material. So, to understand that, I used to give this example, and I find it actually funny but very useful to keep things in mind. Imagine that you actually go to a party, and then you just see a lot of people dancing. So let's take this guy, or this girl, whatever. So, well, let's make her blonde. Okay, this is the haircut. And this girl is dancing. So this girl is dancing. She could be actually just twisting. So she's dancing like twisting, right? Right, up, up. This is one way of dancing. So she would have a certain energy in dancing. Another girl would be, for example, I don't know, for the boy in front of her, let's say, he's opening his hands and just moving them up and down, which most of the boys do all the time. They just dance with the hands, okay? So this is also is another type of energy, just opening and closing your hands, your arms. Great. Another person can do both, right? So you can actually turn around and jump and etc. and revolution, and you do a lot of things when dancing. All these things just are due to the fact that you, as a person dancing around, you have a certain dimension in space, and you are using your energy to actually move yourself in the space. This is exactly what the molecule does. The molecule dances in a material. So these two hydrogen atoms could be actually just dancing up and down, while the oxygen atom is actually moving also up and down in a very nice harmony. So the whole molecule would be just vibrating, contracting and expanding, contracting and expanding. And at the same time, the molecule could be, you could imagine it, if you hold it by here, and then it could be actually just turning around itself, rotating around itself. So it could be rotating around itself and moving at the same time. So now that we are on in inline sort of things, we see these things now for real. So let me try to rotation of a molecule. Can I see that as a video? Rotation is easy to be honest, but yeah. Let's see if you can see that. Well, it might be taking time. Anyway, we will give it the time to load, and voila. So that's not exactly what I meant, but yeah, I will figure it out. Rotation of the H2O molecule. Voila. Let's have a look. Okay, so this is how the water molecule would be rotating actually. Okay, now if we look to the vibration of this molecule, well, the vibration is like this, with the two arms. So I was making fun by dancing, but that's actually really dancing of the molecule. Okay, so basically the molecule is just dancing, right? And that's really nice. This is what molecules do. So look to the CO2 molecule now. It will also be dancing in this vibration sort of thing. But it can be doing both. So it can be vibrating and basically rotating at the same time. If you put just some music into this YouTube video, you will make a very nice, basically, dancing movie. So this is what molecules do in matter, right? And this is what we are going to probe. We are going to probe the rotation energy, or the energy of the molecule during its rotation. So this will tell us actually what is the shape of the molecule. Shape of the molecule means what is the size of the bond, the dimension of the bond, what is it made of, etc., etc. Same thing for the vibration, and same thing for the vibration rotation. This will change the response. So I will send a certain light, as I said at the beginning. If the interaction, or if this light interacts with a vibrating molecule, it will send back light out of the material with a certain frequency. If, however, it interacts with a rotating molecule, it will send light with a different frequency. If it interacts with a vibrating and rotating molecule at the same time, it will also send a different type of frequency. So this is why the type of the interaction defines, or is defined if you want, by the frequency and energy of the light that we collect after the light interacts with the material. So this is going to be the whole thing. So the very basic notions, you most probably know them. I'm going, however, to talk about them as quickly as possible now, time-wise, because I think for some people, after 20 minutes, it's going to be, electricity is going to be off. So I'm not going to stay until 12 o'clock. So we'll try to finish earlier, and then we continue later. Basic notions. Before I start, does anybody have any questions so far? No?
I just want to say that we have about 7 minutes available, because Zoom doesn't let us have more than 40-minute lecture.
Okay.
Yeah.
Doctor, I wanted to ask the slides, where are they available?
Okay, so look what I will do. Since it's a 40-minute lecture, and anyway, we are going to be short on the electricity time for a few of us. For me, it's not going to be a problem because the electricity will come, but for some of you, it will go away, so it will take time to reconnect. So let's stop the session here, and I will do the continuity as a recording, so you read it, and we will see. I will tell you. These slides are available on the internet, on the website. Well, the internet, on my website. So if you go to the link that I sent to you, I think I sent you that. Not this. Do you have the link to the website? You do, right?
Yes.
Okay. So it's on the.
I have link for the, but it can't be open.
No, it can actually. I changed the settings for that, because at the beginning. Oh no, the internet is running. So, well, you will have it. I will. Okay. So I will show you where you can get that on the internet, on the website. So you won't need to go through all that. You will just have the link. So you will have the link, and you can use it to. Just give me some time, voila. Okay. Well, you have, when you open the link, you will get this, right? So if you go to teaching, this academic here, so you select your course, Molecular Physics Spectroscopy. So you will have these different possibilities, right? The online sessions, I will put this session now, when we finish it, I will put it recorded online here as a YouTube video. It will be private, but your addresses, your email addresses will have access to it. And course slides, if you click there, come on. Okay. Okay. You will find it here. So I see now that I have now seconds to finish. Okay. After 40 minutes, it might stop. So if it stops, I will record it, and please on WhatsApp, I would like on WhatsApp to just discuss with you very quickly by your voice messages any feedback, because I'm interested to know the feedback about this experience now with the online thing. It's new to me like this, so there will be a lot of things that I would like to change next time. Okay, well, thank you very much. 8 seconds. We will keep on. Well, actually, it went more than 40 minutes. We are not off. Good. So I'll keep on finishing what I wanted to say. This is where you can find it, okay? And it is available. Now it has been made available, so you can download them. You will have all the chapters, by the way. And these slides are the ones that I will be showing to you. So you can already have it, download it here. It's in a PDF format. This is where you can find it. The textbook is, if you go to molecular physics in textbooks, the textbook that I personally advise you to read, I mean, all are good, but I personally prefer one of them. It's the Barrow Introduction to Molecular Spectroscopy. Okay, Physics of Atoms and Molecules by Bransden and Joachim is good, but that is a bit more fundamental about the molecular physics fundamental aspects rather than the spectroscopy itself. This one is really very good and very easy to read, and it's also available, and you can download it now.